Okay, in this video, we're going to look at adding and subtracting rational expressions with unlike denominators. So if you remember from fraction arithmetic, in order to add or subtract fractions, you must have like denominators. So if we start off with unlike denominators, we got to do some work before we can do that adding or subtracting. We need to find, in order to add or subtract, the least common denominator. The least common denominator is also known as the least common multiple. You can find a common denominator by multiplying the two denominators together, but it won't necessarily be your least common denominator. But in this case, like in example 1, 7 and 5 don't share any factors. So in this case, the least common denominator is going to be 7 times 5, or 35. So in order to turn each of these fractions into a fraction with a denominator of 35, we build our common denominators through multiplication. So what would we have to multiply 7 by to turn it into 35? Well, we'd have to multiply it by 5. But we can't do that to the 7 without doing it to the 6 also. So we have to multiply that entire fraction by 5 over 5. And our second fraction is 4/5. What would we have to multiply 5 by to get that common denominator of 35? Well, we would have to multiply it by 7. And if we do that to the bottom, we have to do that to the top also. So what we have here, 6 times 5 is 30 over our new common denominator of 35, plus 4 times 7 is 28 over our new common denominator of 35. And once we have that matching common denominator, we just add those numerators. 30 plus 28 is 58. That can't be reduced at all, and we're okay with improper fractions, so we'll just leave it like that. Next example, number 2. This time we have two denominators, 9, which is made up of 3 times 3, and 3, which is just prime. We can't break that down any further. And so to find our least common denominator, anything that matches on our list of factors here, we just copy down once. And we have to include anything else that doesn't match. So our least common denominator is going to be 3 times 3, which is 9. That means that first fraction doesn't have to be changed at all. It already has a common denominator. But 1/3 does need to be changed. We multiply that by 3 over 3 in order to get that common denominator. So we get 7 over 9 minus 3 over 9, which is 4 over 9. Next up, we're going to throw some variables in here now. So our two denominators this time are 5x, which is obviously just 5 times x, and 6x, which can be broken down into 2 times 3 times x. So we break it down into its prime factors, and that means the least common denominator in this case. Well, the x's are shared, so we only need to include that once in our common denominator, but none of our factors are shared, so we need to multiply all 3 of those numbers together. So 5 times 2 times 3, that means our LCD is going to be 30x. Okay, so we are starting with 1 over 5x. We want to turn that into 30x, so we have to multiply by 6 over 6. And for our second fraction, we are starting with 5 over 6x. We want that to be a 30x in the denominator also, so that one has to be multiplied by 5 over 5. Remember, multiplying fractions, we just multiply the tops and multiply the bottoms. So this first fraction, 1 times 6 is 6. 5x times 6 is 30x. The second one, 5 times 5 is 25. And 6x times 5 is 30x. Now that we have those common denominators, we can just add the tops. 6 plus 25 is 31. And we keep that common denominator. There is our answer for number 3. Number 4, our denominators are x squared, which is x times x, and x cubed, which is x times x times x. So our LCD, we need to include an x for that pair, another x for that pair, and then we have to bring down that final x. So our LCD is going to be x cubed. That means 7 over x squared we need to multiply by x over x to get an x cubed in the denominator, minus 6 over x cubed. That one already has the common denominator, so we don't have to change it at all. So again, multiplying 7 times x and x squared times x. We now have that common denominator. Now notice up top, 7x minus 6, those are not like terms. We cannot combine them. So we just write them out as we see it, 7x minus 6 over x cubed. There would be our final answer. Okay, we're gonna actually skip number 5, go on and look at number 6. Remember, when we have a whole number, that's really the same as that number over 1. The denominator is 1. So if we need a common denominator between x and 1, that least common denominator would just be x. So the first fraction remains unchanged. Second fraction, 5 over 1, we need to multiply that by x over x. So we end up with 8 over x plus 5x over x. And again, we'll add across the top. Those two are not like terms, so they cannot be combined. We just write it out, 8 plus 5x over x. And we can't cancel those x's. Remember up top, we have two separate terms, not factors. So we would leave our final answer just like that. That's as simplified as we can get it. Okay, now we're going to move into denominators that have multiple terms. Let's put a little note for ourselves in here. You have to factor first before figuring out what your common denominator is going to be. Okay, factor first. So before we work this problem, let's factor this first denominator. There's a GCF there. The second denominator doesn't factor at all, so there we go. Now let's think about it. Our LCD, okay, well, it's got to include a 3. That comes from the first denominator. It's also got to include a y minus 5. That comes from the first denominator, so the first denominator is covered. The second denominator is y minus 5. We've already got that in here, so this will be our LCD. So when we rewrite, we don't have to change the first fraction at all. It's already got the common denominator. But our second fraction is missing that coefficient of 3. So we need to multiply the top and the bottom by 3 to get that common denominator. Still not changing that first fraction. For our second fraction, 2 times 3 is 6. And I'm just going to write that coefficient in front because I prefer it that way. Oops. That should have been y minus 5. Now that I have a common denominator, that's going to be my denominator. And I just do the arithmetic across the top. 1 plus 6 is 7. There is my answer. Okay, another one. We need to factor the denominators first. So let's start there. We need to factor this denominator from our first fraction. D squared is d times d. And 3 can only be 3 times 1. Check on our signs. To get a negative 2d in the middle, we need a minus and a plus. And that means that our LCD for this one has to include all the factors from our first denominator. And the second denominator is already covered. There's already a d plus 1 in there, so that's good to go. There's our LCD. So the first fraction is already all set. I don't have to change anything there. But that second fraction only has d plus 1 in the denominator. We need it to also have a d minus 3. So we multiply the top and the bottom by d minus 3. Now we're set up. We have that common denominator. And we do the arithmetic across the top. We get d plus, we can go ahead and distribute this 8 as we're rewriting it. So it's d plus 8d minus 24. Combine our like terms, we get 9d minus 24. Oops, I accidentally cut. Did you guys see that? Oh, that should have been a minus right there. Sorry, I copied it wrong when I recopied it. Fix that up. Okay, sorry, d plus 1, d minus 3. And then we're not quite done. It looks like the top of that could be factored. 9 and 24 share a common factor of 3, so let's pull out that GCF. So that would be our final answer. Okay, so we're going to do that same procedure on just a few more examples so you can see it worked again, but they will be very similar to the ones we've done so far. We're going to skip number 9 and go to number 10. Remember what we said, factor first. So let's factor each of these denominators before we try to figure out what the LCD is. For this first one, we can pull out an x. For the second one, we can also pull out an x. So our least common denominator has to include an x. It has to include an x minus 3, and it also has to include an x plus 3. We want to multiply all those factors together to get our LCD. So that means our first fraction, it doesn't have the common denominator yet. It's missing what? It's missing an x plus 3. And then we'll write down the second fraction in its factored form. And it does not have our common denominator yet. What's that one missing? That one is missing the x minus 3. Okay, there we go. Now we've built everything to have this common denominator. And we need to do the arithmetic across the top in our numerators. Let's get another color going here. So here I'm going to distribute this 2. So I end up with 2x plus 6. And here, be careful, this is a minus. So I am going to distribute a -1 to make sure I'm subtracting those fractions. So I end up with a minus x, but then a plus 3, because that -1 times -3 gives me a positive 3. Next up, combine your like terms. Up top, we have 2x minus x. Then we have 6 plus 3. And we'll just leave that common denominator the same. There's no reason to multiply out that denominator. Just leave it in its factored form. It's easier that way anyway. Okay, we'll do just a couple more examples. Number 11. The denominators are already factored, and they don't share any common factors. So our least common denominator is just going to be those two factors multiplied together. So as I'm building my common denominator, the first fraction is missing. It's x plus 7. Keep in mind, this one is a subtraction, so be careful. That second fraction has the x plus 7, but it is missing the x minus 2. Okay, we've built ourselves this nice little common denominator. So we just copy that down, and then we do the arithmetic across the top. Again, we'll distribute here. So we get 6x plus 42. Be careful, again, we are subtracting our fractions, so we're going to end up distributing a -4. So we get minus 4x plus 8, because -4 times -2 gives us a positive 8. Combine our like terms. 6x minus 4x is 2x, and 42 plus 8 is 50. And I'll go ahead and factor the top. We do have a GCF there. And there is our final answer on that one. Okay, next up, we're going to do number 12. The one thing that's a little bit different about number 12 is we now have 3 fractions that we're looking at. The denominators can't be factored, so the denominators are fine where they are. The least common denominator in this case has got to have an x minus 1 in it. From that second fraction, it also needs an x plus 1. And the third fraction, we're already covered. We got the x minus 1 there. So there's our LCD. So let's start building. There's our first fraction. What's it missing? Well, it's missing the x plus 1. And then our second fraction is minus 3 over x plus 1. And that one is missing our x minus 1. And then our third fraction was x over x minus 1. And that one is missing an x plus 1. Okay, so let's put it all together. We now have that common denominator of x minus 1, x plus 1 on every one of those fractions. I'm probably going to run out of room here. I maybe should have written it on the next line. We'll see what we can do. So for this first part here, I'm going to have to FOIL that out. So I'm going to get a 2x squared and then a 2x and an x. So those add up to 3x. And then 1 times 1. That's the FOIL from the first part. Again here, be careful with that negative sign. I'm going to distribute that negative 3. So I get minus 3x plus 3. And then here, I'm distributing a positive x. So I get plus x squared plus x. Oh, look, I fit it all in there. Okay, gather up your like terms. I see a 2x squared and an x squared. So those add together to give us 3x squared. On my x's, I see a positive 3x and a negative 3x, so those knock each other out, and then I just have a plus x remaining. And then a 1 and a 3 gives me a plus 4. Looking good. Now we should take a look. Can we factor the top? That is a trinomial. Let's think about it. 3 times 4 is 12. And our middle term is 1. Well, 12 is 3 times 4. That's good. But to get a 1, we'd need a minus 3 and a plus 4, and that does not give us that 12 at the top. So it turns out this one does not factor. We'll leave it just like that. Okay, let's work a couple from this page also. We'll look at number 14. Again, factor first. So we want to take a look at that first denominator. And it turns out that factors into x times x. 64 could be 8 times 8. And if they are both positive, we get that 16 in the middle. So our LCD, to cover the first fraction, we need x plus 8, and we need it twice. And the second fraction, x plus 8, is already covered. The first fraction already has our LCD, so we don't have to do anything to it. Our second fraction has 1x plus 8, but to match, we need it to have 2x plus 8s multiplied together. So we've made our common denominator. I'm going to write it x plus 8 squared, just shortcut, save a little time. We have the x minus 4. And then here in our second fraction, we'll need to FOIL to multiply that out. So we get an x squared. We get an 8x and a minus x. And then we get negative 1 times 8. Combine our like terms. And I'm going to reorder them too. So my x squared term is first. X squared. We have an x and a 7x. So that gives us 8x minus 12. We should take a minute. Does the top factor? We'd be looking for factors of negative 12 that will add to give us 8. And let's see, negative 12 and 8. 12 is 2 times 6, which does give us 8. But to get a positive 8, they'd have to both be positive or both be negative. And in that case, we can't get a negative 12. So we'll just stop right there for our final answer. Okay, and then I'm going to do number 15. I think that'll be our last example. You could try 16 and 17 for fun on your own if you like. Before we start number 15, factor the denominator. That first one is the difference of 2 squares. And then let's think about what our LCD would be. For our first fraction, we need a p minus 4 and a p plus 4. For our second fraction, we need a p. Now you're thinking we already have a p here. We have a p minus 4 and a p plus 4, but we need a single p as a standalone factor. We need to multiply that p. Those p's that are in our factors already don't count. But our third fraction has a p plus 4. That is already covered. So there is our LCD. So let's build our common denominator. Write down that first fraction. So what's missing here from our common denominator? We're missing that p by itself. So we need to multiply that one by p over p. Write down our second fraction. What's missing from this one? Well, we're missing two things. We're missing a p minus 4 and a p plus 4. Write down that third fraction. Oops, I want that to be purple, sorry. Write down that third fraction. That one's got the p plus 4, but it is missing the p and the p minus 4. Okay, there we go. We did it. We built a common denominator. Now we got to write it all out together. So our new denominator is p times p minus 4, p plus 4. And then our numerator, let's see, right here we end up with 4p times p. So that first one gives us a 4p squared. The second one, I think I'm going to have to do this in 2 steps. Let's leave that minus 2 alone and go ahead and multiply out the p plus 4 and the p minus 4. Remember, that is p squared minus 16. You can FOIL it out to check. And then here on our last one, I'll kind of do that in 2 steps too. So we have minus 2p times quantity p minus 4. Okay, so we still got some work to do up top. Leave the bottom alone, leave it factored. It's nice the way it is. 4p squared. We'll go ahead and now distribute here that negative 2. So we get a minus 2p squared and a plus 32. And then we'll distribute again here the negative 2p. So we get a minus 2p squared and a plus 8p. I'm going to scroll down a little bit, give me a little more space. Okay, collect up our like terms. For p squared, we have a 4p and a minus 2 and a minus 2. So 4p squared minus 2p squared minus 2p squared, they just cancel each other out altogether. That leaves us with 32 plus 8p. And that top can be factored. 32 and 8 share a common factor of 8. Then there's one more step. The fun never ends here. What else can we do? Take a look. 4 plus p, that is actually equivalent to p plus 4. Addition is commutative. We could change the order there. So those two are actually the same factor, so we can cancel them out. And our final answer then would be 8 over p times p minus 4. And that's it.